All right, so question number 3 on your problem set asks you to draw the isomerization reaction of phosphoglucose isomerase. All right, so the reactant that we're going to start off with here is phosphoglucose, so glucose 6-phosphate specifically. All right, so this is the second step of glycolysis. Now, in any isomerization reactions where we're trying to basically move a carbonyl compound from a carbonyl group from one location on the molecule to another. All right, so the way that we're going to be doing that, we want to get to an enediol intermediate. All right, so right now, basically our carbonyl, it's not explicitly shown on here, but it's actually present on carbon 1 here. All right, the way we know that is we want to look for the carbon that has 2 oxygens bound to it. That's always going to be our carbonyl, carbon in a sugar like this. All right, so the first thing we have to do is we have to expose that carbonyl group. All right, we do this by basically opening up the ring. All right, well, I said that this carbon is going to be the one that has the carbonyl group on it, right? And the oxygen is bound only to that carbon is going to be the carbonyl oxygen. So we're going to deprotonate this oxygen. Its electrons are going to collapse back down, forming the carbonyl, and then we're going to protonate the hydroxyl. So the ring oxygen here as actually a hydroxyl group belonging to carbon 5. So if you remember from the sugar chapter, that's how we form the ring structure on these sugars. All right, now once we've done that, so our carbon 5 is protonated, has its hydroxyl group on it. We now have a carbonyl here on carbon 1. All right, to get to our enediol intermediate, we're always going to deprotonate the hydrogen or remove the hydrogen that is right next to our carbonyl. So the base is going to deprotonate and remove the H+. The electrons from that bond are going to form the alkene, and that'll push the electrons from the carbonyl up, and they can get protonated in the active site. All right. And now we end up with our enediol. So we have that alkene with 2 hydroxyl groups on either side. All right. Now, in order to shift the carbonyl, all we have to do is deprotonate the other hydroxyl. All right, if we deprotonated this first one, we could do that, but we're just going to end up with the aldehyde again. All right, so we can deprotonate either one, just only one way gives us the productive chemistry. So we're going to deprotonate the other alcohol, carbon 2. So a base is going to grab that H+, that frees up the lone pair of electrons to form our carbonyl. And now the alkene, those electrons are going to go get protonated from some acid in the active site. They'll grab an H+ from it and push the electrons over to that acid. All right. And now at this point, all right, we've now effectively moved that carbonyl over to carbon number 2. All right. Now at this stage, our sugars are going to end up being the cyclic ring forms again, predominantly in solution. All right. So in order to recyclize, we have to have the alcoholic carbon 5 attack the carbonyl carbon to form the ring. All right, and so to do this, we make the hydroxyl group a better nucleophile by deprotonating. All right, that allows it to do a nucleophilic attack, which pushes the electrons up onto the oxygen and then allows them to grab an H+, and the H+ leaves behind its electrons on that acid. All right, and now we have formed here our fructose 6-phosphate sugar in the end.